In this video, we will discuss the concept of infinite limits. As the name itself tells, infinite limits means the limit value goes to infinity. Limit is infinity. That means as x goes to a number, either from the right or from the left, the y value goes to either positive infinity or negative infinity. The infinite limits are represented in the following 6 ways. You could have an infinite limit as x approaches a from the right, the y value approaches positive infinity. That means the graph of such a function would look like this. This is x equals a, and the y value approaches positive infinity as x approaches a from the right. The limit approaches negative infinity as x approaches a from the right. That means you could have a graph like this. The left-hand limit at a is positive infinity. That means as x approaches a from the left, the y value approaches positive infinity. The left-hand limit at a for the function is negative infinity. The graphical representation for that is this. So as x approaches a from the left, the y value approaches negative infinity. And here the limit the limit of the function is positive infinity as x approaches a. That means the left-hand limit is positive infinity and the right limit is positive infinity. So the graph would look like this. And here the limit of the function is negative infinity as x approaches a. That means the graph of such a function would look like this. So as x approaches a, the y value approaches negative infinity. So these are the graphical representations for the infinite limits. Any of the 6 things could represent infinite limits. In all the 6 cases, we have that x equals a is vertical asymptote of the function. So in the second case as well, x equals a is the vertical asymptote. So is in all the rest of the cases. So infinite limit means as the y value goes to positive or negative infinity as x approaches a number either from the right or the left. And the 6 possible representations of the limits at infinity are the following ways, and they are geometrically represented in the following ways. And infinite limits are always associated with the vertical asymptote. That means if x equals a is the vertical asymptote, then you have an infinite limit as x approaches a either from the right or from the left or both. You could also, if the limit of the function approaches positive or negative infinity, x equals a represents the vertical asymptote of this function. Now let's go ahead and work on some example problems and evaluate the infinite limits for the functions that are represented graphically. So here is the graph of the function, and here as you can see that the left-hand limit is at 0 for this function is positive infinity. Why does it happen? As x approaches 0 from the right, you see that the y value goes to positive infinity, hence the left-hand limit is positive infinity. Similarly, you see that the right-hand limit for the function at 0 is also positive infinity. Why? Because as x approaches 0 from the right, you see that the y value approaches positive infinity. And you can see that the left-hand limit is equal to the right-hand limit. So the limit of the function as x approaches 0 is going to be positive infinity for this function. And you can also, we learned from the previous slide that the infinite limits are very closely associated with the vertical asymptote. Hence x equals 0 is the vertical asymptote. Now we can also quickly look at the domain of this function. The domain of this function would be negative infinity to 0, union 0 to infinity, and that means 0 does not belong to the domain of the function, and hence x equals 0 is the vertical asymptote. that means the function never reaches the y-axis. It doesn't cut the y-axis, or it doesn't jump across the y-axis, but it gets very close to the y-axis as possible. Now let's look at another example. Here you can see that the left hand, again at 0, you have a vertical asymptote. That means the left hand limit of the function as at 0 is negative infinity. The reason is, as x approaches 0 from the left, you see that the y value approaches negative infinity. Similarly, you have limit x, the right hand limit of the function as x approaches 0 is going to be negative infinity again. So that is because as x approaches 0 from the right, you can see that the y value approaching negative infinity. Here again, you can see that the left hand limit is equal to the right hand limit, and hence you can write that the limit x approaching 0 f of x is going to be negative infinity. Now once again the infinite limits are associated with the vertical asymptotes. So x equals 0 is the vertical asymptote. Once again, if you look at the domain of this function, it's going to be negative infinity to 0 union 0 to infinity. That means 0 is not included in the domain, it's excluded in the domain, and it's very obvious that's because you have the vertical asymptote at x equals 0. Now let's look at another example. This is the graph of y equals 1 over x. So you can see that the left hand limit for this function at 0 is going to be negative infinity. That's because as x approaches 0, you can see y goes to negative infinity here. And the right hand limit for the function as x approaches 0 is going to be positive infinity. The reason is, as x approaches 0 from the right, you can see that the y value approaches positive infinity. And you can see that the left hand limit is not equal to the right hand limit, and hence limit x going to 0 f of x does not exist. Now it does not exist. And also you can see that because of the one-sided infinite limit, you can see that x equals 0 is the vertical asymptote of this function, and the domain of the function is negative infinity to 0 union 0 to infinity. Now let's look at one last example for the infinite limit. However, I mean, you can quickly see that this would be the graph of f of x is going to be negative 1 over x minus 1. It's a rational function, so sorry, x plus 1, so that means you're really moving graph to the left by 1 unit, and it's a rational function, so you will have an asymptote at x equals negative 1. And you can see that the left hand limit of the function at negative 1 is going to be positive infinity, and the right hand limit of the function at the negative 1 is going to be negative infinity. You can see that the left hand limit in this case is not equal to the right hand limit, hence the limit of the function as x approaches negative 1 does not exist. However, because of the infinite one-sided infinite limit, you can clearly see that x equals negative 1 is the vertical asymptote of this graph, or the vertical asymptote of this function, and the domain of the function is going to be negative infinity to negative infinity to negative 1 union negative 1 to positive infinity. That means negative 1 is really excluded from this, negative 1 is excluded from the domain of this function. I hope this makes the concept of infinite limits and its correspondence with vertical asymptote clear. If you have any questions, please write to me in the comments below.